Now we're going to go with problem 2, and it's really similar. It's a limiting reactant problem. That's why there's these 2 stoichiometry problems already set up so we can compare the 2 starting reactants, see which one makes more products. If 100 grams of Al2O3 is reacted with 100 grams of Fe, determine the limiting reagent. Reagent's just another word for reactant. So start by writing 100 grams, which is what we know, of Al2O3, and 100 grams of Fe. And before I get started, I'm just going to look at B and C to see if we need to pick one of our 2 products to solve for. So B, determine the number of grams of Al produced. So it's asking me for the theoretical yield, and determine the number of grams of Fe3O4. So I actually need to find both products eventually. So for now, I'm just going to choose this one to solve for at the top. And when we get to B, I'll explain how to do that one in a minute when we get there. So I'm going to get both of these into grams of Fe3O4. So I'm going to just go ahead and write that at the end because I know that that's what I'm trying to end in for both of these. So in my top one, since I have grams of Al2O3 at the top, I put it at the bottom so it cancels. And I put 1 mole of Al2O3 at the top. So let's go ahead and find my molar mass. So Al is 27. O is 16 grams. So we have 27 times 2, 16 times 3. 27 times 2 is 54. 16 times 3 is 48, so we add 54 and 48. 102. My next step is to do my molar ratio between my reactant to the product I'm trying to find. So I put Al2O3 at the bottom, Fe3O4 at the top, and I'm going to fill in my ratio. So in front of my Al2O3, I have a 4. In front of my Fe3O4, I have a 3. So I should end up with 3/4. Finally, I don't want to be in moles of Fe3O4. I want to be in grams. So I cancel my moles. I write 1 mole of Fe3O4 at the bottom here. And over here, I'm going to fill in the molar mass. So Fe has a mass of 56. I already know that from the previous problem. Times 3 Fe's. So 56 times 3 is 168. Then we got O, which is 16 times 4, so 64. And then I add 168 and 64. This time I'm going to get it right and not embarrass myself. I have 232. So now I'm going to multiply everything in my numerator and write that number down. So I have 100 times 3 times 232. So 69600. And everything in my denominator, so I have 102 times 4. Oops. 408. And I'm going to divide 69,600 by 408. And I got 170.58. So 171 grams. So I wrote 171 grams of Fe3O4. So now for this bottom one, I'm going to go ahead and let you guys fill this in. Don't forget that these 2 top ones should be identical to this one, because in this problem here, we're also going to end in grams of Fe3O4. So I'm going to let you fill this in, and then you can check your work when you're ready.
Can I tell you something just between you and me? When I hear your voice,
So this is the answer I got. I got that, 100 grams of Fe gets me 138 grams of Fe3O4. Take a minute now and just check to see that you have the same numbers as me. So what that means is that Fe was limiting because it made less product, and Al2O3 was excess, it made more product. So let's go ahead and label those. And we already have our answer to C because we determined the number of grams of Fe3O4 produced because that's just the answer to the limiting reactant, which was 138 grams. So I'm going to go ahead and write in my answer here. You can write from A. And the only other one I need to do is determine the number of grams of Al produced. So it wants us to figure out how much of the other product could we make. So you always, when you're doing this, start with your limiting. And this should go a little faster now because we've done a lot of our molar mass calculations and everything before. So we're going to start with our limiting reactant, which was 100 grams of Fe. And we're going to see how many grams of aluminum that 100 grams of Fe could make. And we're using the Fe because it was limiting. So it's going to limit the amount of both products that are made. So again, I'm going to just set up my 4-step stoichiometry problem. And Fe was 56. My ratio of Fe and Al is 8 Al to 9 Fe. So 8 over 9. 1 mole of Al has a mass of 27 grams. And I just get that by looking up Al on the periodic table. And okay, so that went pretty quick. So I'm going to multiply everything in my top. 100 times 8 times 27. And 56 times 9 is in my denominator. So then I just divide 21,600 by 504. 42, so 43 grams of Al. So those are some pretty long problems. I hope you guys are feeling proud of yourself. We're getting into some real deep stoichiometry here. These are the longest problems that you're going to see. And so if you understood today, you are set to go. If you still need additional help, please feel free to call me during my office hours or send me a text or email, and I'm happy to help you. I'm also happy to send you other videos. Of course, you're welcome to rewatch this one. Please do the problem on the next slide and see how that goes for you. I'll post answers to that as well, and then go ahead and do your exit ticket. Hope you guys have a great afternoon or evening or morning, depending on when you're watching this.